used
Okay.
to use that, Josh. So
So,
watch out.
find equations of tangent lines again today, but now we're going to be using derivatives to find the slope of the tangent line, and be able to find derivatives using numerical values. Oh, I'm sorry. I don't know why I'm so yawny today. Waiting for everyone to sit down. Okay, so we're actually going to start with our second goal, solving derivatives using numerical values. So if we know two functions, u and v, they are functions of x, and we know some of the values, we know u of 1 is 5, u prime of 1 is -2, v of 1 is 3, and v prime of 1 is 4. We want to still be able to find derivatives even if it's kind of in a more general form. We want to be able to take derivatives of two functions multiplied together when we just call them u and v instead of saying u is x squared plus 7 and v is sine x. We want to still be able to take the derivative of things like this. And there are questions like this on the AP test where it is in more general form, where they say find the derivative of h of g of x, or find the derivative of p of x times q of x. So for this first example, we are trying to find the derivative of a product. What rule do we have to use to find the derivative of a product? Product rule. Well, if we're doing derivative of a product, we have u, we have v. What's the derivative of u? How do I say u has a derivative when I don't really know what u is? U prime. So derivative of u is u prime. Derivative of v is v prime. And then we just go low-de high, high-de low. So y prime would be second v times derivative of the first plus first times derivative of the second. It's just product rule. It's in fact the formula for product rule. But when we're presented with it in this form, we get stuck because it's not an actual function. We don't like working with things if they don't tell us what the function is. So how would I then find y prime of 1? Do we know what v of 1 is?
Yes.
Do we know what u prime of 1 is?
Yes. Yes.
We just have to plug it in anywhere, everywhere. What if I wanted to know y prime of 2? Plug it in again, but what would I do? Because I know what v1 is. What's v1? 3. What's u prime 1? U of 1 is 5. V prime of 1 is 4. If I asked you to find y of 2, or y prime of 2, you'd be out of luck unless I gave you more information. We could plug it in and say, well, v of 2 times u prime of 2 plus u of 2 times v prime of 2, but we'd have to stop there. There is nothing else we can do because I didn't tell you what u of 2 is, and I didn't give you a function so you could find what u of 2 is. So now we simplify. -6 plus 20 is 14. So now you guys try one.
Still the same numbers.
Still the same numbers. So what should we get? Negative 26 over 9. I checked everyone's and everyone did fine, so we're not going to go through that again. You've all done it.
So are the numbers not the same? It just depends, like, in each problem?
In the problems I've assigned on the homework, there's 2 of them, but they have a part A, B, C, and D. So the numbers are the same for A, B, C, and D, but then you'll have a second problem.
So it's just
Different
whatever
numbers.
they tell you they are? Okay.
So, where this is used more often in the AP test is they give you a table of numbers, which makes it a little harder. So, let's still do this one, but let's present it differently. They would do more like u of x, v of x, u prime of x, v prime of x. And here's our x values. So they would actually give you a very large table. And on these problems, there's never any way to plug in 1 into this as an entire function and get different things, but when we learn what's called chain rule, I could say find y prime of 1 and give you something, and when you plug in 1 within the process, you've actually got to find a 2 value somewhere or a 3 value somewhere on your table. So it is possible, and we'll see problems like that later. What were our u prime, v prime values?
U was 5. U prime is -2. U is 3. U prime is 4.
So we'd have a whole bunch of values. So something like this, it's super straightforward and we wouldn't need really an entire table, which is why they don't make one. But if I did something like y is equal to h of g of x, actually let's use our u and v. Eventually you'll learn that the rule for this, for a composition of functions, is derivative of the outside evaluated at the inside times the derivative of the inside. So when we plug in 1, you don't have to write this down. This is just to show you why we would need it in table form. When you plug in 1, v of 1 is -2.
It's 3. It's actually 3 though, so it's the middle too.
Oh, sorry. That is actually advantageous. So v of 1 is 3, and then we'd have to go back to our table and find u prime of 3. So that's why we would need an entire table involved in it. For now, they're not going to give you a table, they're just going to give you a list of values, because we don't have the information to do a problem like this yet, where you would have to go and kind of jump around the entire table. We'll learn chain rule in chapter 4. So, high five. Why? You have to circle and tap. It should erase it. I don't know why it wasn't working for me. So if I took the derivative of this, how do I find the derivative of 5u?
Wouldn't it be 5?
Okay. This is a function though. This is 5 times u of x plus 8 times v of x.
Right.
it's a function, not a variable. So we can't treat it like it's a variable.
Plug the value in for u of 1.
Not yet. We can't plug in the value until after we've taken the derivative. If I say I have a function u, how do I represent this is the function's derivative? Not yet. We can't do that. Otherwise, we'll just have constants. We take the derivative, we get 0. What's the derivative of u? If I just said, I have a function u. U prime.
Prime. So is it just 5 u prime?
So it's just 5.
Oh, we're just overthinking too.
Okay, you're trying to overthink it.
That's why I got it.
5 u prime. So what would the derivative of 8 v of x be? 8 v prime. Now after we've taken the derivative, now we can plug in the value of 1. We want to know specifically what is the value of the derivative at 1, because that's what it told us to find. Y prime of 1 is, we know u prime of 1 is -2, and v prime of 1 is 4, and then we just simplify. -10 plus 32 equals 22. Get rid of this table really quick. Why is it not working today? That's why it worked earlier in the day.
I love the lag. It's great.
Yeah. So what if we want to find the equation of a tangent line now? When we found the equation of a tangent line in chapter 2, we had to do the limit as h goes to 0 of f of x plus h minus f of x all over h. And usually it told us that x equals 1. So when we're finding equations of tangent lines, what 3 things did we need to find the equation of a tangent line?
The x value,
X value,
y value,
y value,
the slope.
and the slope. X value, y value, they're normal, no calculus involved. X, we know, is 1. How would I find the y value? Plug it in. 1 to the 5th plus 7 times 1 squared over 1 cubed is 8 over 1, or 8. So x value, y value, we did not do any calculus. But now when we find slope, what do we know slope really is? We have lots of words for slope now. Instantaneous rate of change. What else? Derivative. We know slope is derivative. Now when we take the derivative, we usually get a derivative function. It's gathered up all the patterns of all the slopes everywhere. We saw that when we did our dragging the point on our document in the Inspire. It gathered up all the points formed a pattern, and we made an equation out of that. What if I want to just isolate one of those points? We plug in the x value after we've taken the derivative. So now when we find slope, we take derivative, and plug in the x value. For our position function, our regular function, when we plug in x, we get the y value. We get position, but if we take the derivative and plug in an x value, we get our speed, or our slope. So how can I go about taking the derivative of this?
Bring the x cubed.
Okay, you could think of it that way, but if we did that, we'd then have to distribute x to the negative 3n, which sometimes makes your brain hurt. Okay, we could use quotient rule. It's already set up as a quotient. But what was our tricky way to make this easier on us?
Distribute the denominator.
So divide it into both. It's like you're distributing the denominator in, but you're more comfortable with the process of dividing that than distributing a negative exponent. But you really can think of it either way. So if we divide x to the 5th by x to the 3rd, what do we get?
X squared.
X squared plus 7 to minus 3 will give us x to the negative 1. Or we could have done quotient rule. But quotient rule is a lot harder. We want to make our lives easier as possible. Except for Ben's. Nothing?
Funny thing, I don't think,
He's so focused. Man. What's the point of
Yes,
making
John.
fun of people if they don't react?
Good question. See, I'm smart enough to understand that concept.
Okay, so we take the derivative. We get 2x minus 7x to the negative 2. And we're not done yet on this one because we specifically wanted slope when x is 1. We want to know what is that one tangent line doing on my original graph. So I plug in 1. 2 times 1 minus 7 times 1 to the negative 2. Now normally we do have to move negative exponents back down, but 1 to anything, still 1. So since x was 1, I'm not going to bother moving the exponent back down. So we get 2 minus 7, which is negative 5. And then how do we find the equation of a tangent line?
We
Use one specific point slope. Y minus y1. So y minus 8 equals m times x minus 1. And then we simplify. We distributed negative 5. What if I wanted the normal line?
then you would use 1/5.
You use 1/5. What if I wanted a line perpendicular to the tangent line? The same thing, but sometimes when they say that first in the book and they don't use the term normal, your brain doesn't connect the two. But saying a line perpendicular to the tangent line and a normal line, same thing. So we should get y equals 13. Don't believe that's a number. Ben?
Yes.
There's a miswritten book? Oh my gosh.
There is.
Calculus book.
What happens?
Gosh. Over.
A lot of information.
Holy cow.
1, 2, 3, 23 and 24. It's like 10 problems. That's about how many I assign every day.
I was just talking about all the words I have to write down.
Oh. Ben has to go to a meeting, so I just wanted to make sure he got this before.
So I didn't have an excuse to complain.
So what if I ask this a little bit differently? What if I said, I want to know what the tangents line are, or where where the tangent lines are when the slope is 2. So before I wanted the actual equation of the tangent line. Now I just want to know, where do these tangent lines occur? When the slope is 2, where is the tangent line happening? So how do we find slope of a function?
We do f of x plus h.
What's our fast way now?
Fabulous.
Take the derivative. Okay? So I can find y prime a whole lot quicker than doing, by using power rule, than by doing limit as f of x plus h minus f of x over h. But this is where I'm saying where the slope equals 2. So what am I going to do with the 2? I didn't tell you what x was. I just told you the slope equals 2. What do we know the derivative is? Slope.
Plug 2 in for y.
Okay. We plug 2 in for y prime, not for x. Because we know y prime is another term for slope. And then I could go solve for x. This one I don't even need to factor anything. I can just add 2 over, divide by 9, and square root it.
Wouldn't it just be 0? Or am I-
If you just plugged in 0, you'd get 2 equals negative 2. It's Friday. Your brains never function as well on Friday.
Okay, I don't know why I was trying to subtract 2. I don't know.
So what's the square root of 4 over 9? Plus or minus? 2 over 3. So that's another way to represent a situation. I could tell you what the slope is instead of telling you the x value where I want to find slope. You can do both. And then the last thing, I think I'm going to skip the example I had planned and maybe talk about it a little bit differently. So what if, what's a good volume cylinder? Do you guys know the volume of a cylinder? Do you know the area of a circle? Do you know the area of a circle?
Pi r
Pi
squared,
r squared.
and that's times height.
Pi r squared times the height of the cylinder.
Struggle.
Did you know a cone is just a third of the volume of a cylinder?
What?
Mine, actually,
No way!
It is. I don't know why, but I know it is. What if I wanted you to find dv dr? Let's say I had a cylinder where my height's always going to be the same, but I might change the radius. So I'm considering height a constant right now because I'm always going to keep the height the same. But I want to change the radius around. Well, dv dr, that's the same as saying take the derivative of this function. But what am I going to do here because I have r squared times h? Now you're probably thinking product rule. because I said times. But we're considering h as a constant. If I had 5r squared, how would we take the derivative of it? 10r.
So you just leave it.
So you just leave h as part of this because we're considering h as a constant right now. That will not always be the case. We can actually do some pretty complicated stuff with things like this. But if I tell you height is constant, let's leave height alone. So it would be 2 pi r times h. I would just take the derivative normally and leave h alone. There is a problem like that where you're going to have to distribute some stuff in first and then use this concept of, it told me this variable is actually a constant. We're considering it as a constant even though it's written as a variable. So if you didn't write this down already, we only have 5 minutes, so it's probably not